और वीडियो भी दिखाना। Good afternoon, everyone. So today our topic is definite integrals and area under curve using definite integrals. So good afternoon, everyone. Today our topic is definite integrals and area using definite integrals. So first we'll be learning integration as limit of sum, and then we'll be following with area under curve and few questions related to area under curve using different types of integration. Okay, so let's do a recall test and solve this question. Okay, so the hint for this question that I'll give you is if you take x square as t, then 2x dx will be dt and x dx can be replaced by dt upon 2. Okay, so then I think the integration will become very easier. It will be like t, uh, it will be dt upon 2 times of t plus 1, and then I think you guys can find the answer. This will be easy for you guys now. Okay, moving ahead, moving ahead. Now, definite integral as a limit of sum. So let's not worry about the headline and let's see what does it want to convey to us. So in this case, first of all, let f of x, see, we are assuming a function called f of x. We are assuming a function called f of x, and the information about f of x that is to be noted is that it is a continuous real valued function which is defined in the interval a to b, both closed. Okay, and now what we have done here is, okay, so like before checking out the image already given, let's see over here. I am showing you just like this. Okay, so if I take two, if I see this is my a and this is my b. Now what I'm doing here is I want to draw two rectangles. Okay, two rectangles which have equal width. All right, which has equal width. Okay, so this spacing between these two rectangles is equal. Okay, let's say h comma h. Okay, now if I do it like this, okay, if I increase the number of rectangles and keep the width same, okay, so you can see, right, what is supposed to be observed here is that, okay, consider a consider a figure. Now I'm drawing that figure again. Okay, so let's see. See, first what I told, consider two rectangles. Okay, whenever you draw two rectangles to this, see, we can find the area of those two rectangles. This is my point B, this is my point A. I can find the area of these two rectangles since I know the width and I know the function, so I know the point values over these. I know the functional values over these points, which will give me the height of that rectangle. Okay, so now I can find the area of this rectangle, but this spacing between the rectangle, leaves out this area that I am shading right now. Okay. So what is if I had more number of rectangles, then can we imagine that this area that is being left out will decrease. Okay. And if this area which is being left out decreases, then summing those area of rectangles will give us area approximately equal to the area under curve. All right. All right. So now what what this figure signifies here is that, see, what it has shown is they have taken n rectangles. See, this point is A where we have started, this point is B where we have ended our interval from A to B. Now what has been done here is this spacing between each rectangle is h. All right, h. So we can see that A plus h has been written, A plus 2h has been written. So the next would have been A plus 3h and so on till we get n rectangles, and nth rectangle, for nth rectangle we can see here A plus nh has been written. All right. So the point of division on x-axis are A plus h, A plus 2h, and so on till A plus n minus 1h and A plus nh. Okay. Where h, what is h? See, how do we define h here? First of all, we should note that this distance that has been given to us in the interval a to b, is b minus a, correct? This distance is b minus a. Now this distance b minus a is supposed to be divided into n parts. So what I'll do is b minus a upon n. Okay, so it becomes my h. Okay, so h is defined from this space. So that is why h has been defined as b minus a upon h has been defined as b minus a upon n. So I hope you guys got this thing from these 2 points. Okay. Now moving on to the next slide. Okay. Now let S of n denote the area of these n rectangles. Okay. So what we have to find the area first of all. Okay. So what this thing is saying is S of n. Let S of n. So S of n is area of rectangle. See, area of rectangle 1 plus 2 plus 3 plus 4. First rectangle, second rectangle, third rectangle, fourth rectangle, so on up to nth rectangle. Now, for us to find these sum, let's go back to the figure and see here. See, we know that this breadth of each rectangle is given by h, correct? Breadth is given by h. Now, we want to find the height of each rectangle. We want to find the height of each rectangle. So this point, if we know the functional value at this point here, if we know the functional value or at these points, see here I'm marking it with red ink. Here these 2 points, 3 points, fourth point, and so on up to this point. Okay, so on up to this point. All right. So if we know the functional value of all these points, then we know the height of the rectangle as well, right? So the functional value at this point is given by f of a. Here it will be given by f of a plus h, and so on till f of a plus nh. All right. So this is how the functional values will be defined. Now I know the height of the rectangle. I know the breadth of the rectangle. Each rectangle has a breadth of h. All right. Each rectangle has a breadth of h. So how to find the area of these rectangles? See, the area of the first rectangle can be written by the breadth into the height f of a. The area of second rectangle can be written by the breadth into the height f of a plus h. The third rectangle can be area of third rectangle can be written as height into f of a plus 2h. F of a plus 2h, f of a plus h, f of a. What are these things? These are the functional values which determine the height of each rectangle. So like this, we will go until h f of a plus n minus 1h. Now, sir, we took n rectangles, but why are we finishing this till only a plus n minus 1 times h? So we'll go back to the figure and see. Here you can see that the height of the nth rectangle is f of a minus 1, f of a plus n minus 1 times h. The f of a plus nh is here, which we are supposed to neglect because we need only this rectangle here. I'll mark it with red ink so that it will be clear to you guys. So see, this till this this point we need the height. So till this point the height comes from the f of a plus n minus 1 h. All right. So that is why the series is ending till f of a plus n minus 1 times h. And clearly now Sn can be written as sum of all these things, correct? Okay. Sn is a very close area to the area of a given region bounded by the curve y equals to f of x axis and the ordinates x equals to a and x equals to b. Okay. So the meaning of this is the area bounded by this curve from A to B. Okay. And the x axis. All right. So here we can write as integration area. We know that integration, what does integration does? It does the area, all right? It tells us the area. So integration a to b f of x dx is written as s of n. But, but, sir, what about these areas? What about these areas? I'll mark it with black ink so that you'll get to understand. See, these areas are again left out, right? If we draw n rectangles, these areas get left out, correct? So how do we achieve a condition where we minimize the error? This area which is getting left out is the error, right? In our calculation. So how do I minimize this error? So what will I do is, see, first there were two rectangles. Then we could have drawn four rectangles. So the again the error area would have been minimized. And since we saw if we increase the number of rectangles, then the area which is left out gets minimized. The area which is left out gets minimized. And hence what do we say is that if I had infinite number of triangles, infinite number of rectangles, okay, if I had infinite number of rectangles, the breadth h would have been so low that the area which comes in this error part would have been infinitesimally small, and we could have neglected that, correct? So this is the point that we need to consider. And now you will see why I told you this is because in the next part here, sir, suddenly there is limit n tendings to infinity. Correct? How come limit n tendings to infinity comes? So this we are doing because we want to minimize the error. All right. If we have infinite number of triangles, the error gets minimized and the error becomes uh, error, error, error becomes infinitely small, which can be neglected. Okay. So this is the beauty of mathematics. All right. So now here we can see as S of n. S of n can be also written as C from this, from this thing. From this thing, it is understood if we want to generalize S of n can be written as H times F of A plus RH. Okay, we are summing the areas. Now R, see, R is going from 0. R is going from 0 to n minus 1. Okay. R is going from 0 to n minus 1, correct? See, first it was only A. In the second term, it was 1 times H. In the third term, it was 2 times H. So hence our R goes from 0 to n minus 1. That is why this statement has been written. This statement has been written over here. Okay. This statement has been written over here. All right. And we have already defined earlier that what is our H value? Our H value is B minus A upon N, B minus A upon N, and hence we have substituted B minus A upon N in these following statements. All right. So this is what we call definite integral. This is what we call definite integral as a limit of sum. Okay. So why this term was included limit in this, because we had to introduce limit n tendings to infinity. All right. So this is clear. We'll move ahead. Okay. An alternative way of describing area under the curve from A to B is that the definite integral A to B is a limiting case of the summation of an infinite series. So do not get, very much confused or scared by these type of statements. If you know the meaning, see what this statement has to say us is that, see, area under the curve, which is also in our mathematical terms, this integration gives us area under the curve. And this integration can also be written as this thing. So only this thing has been written mathematically like this in a confusing way. But this is how books are supposed to be, so we write it like this. Okay. So an alternative way of describing this integration f of x dx is that definite integral is a limiting case of summation, is a limiting case of summation of an infinite series. Which is that infinite series? See here. Here it is, here this is the infinite series. This series is infinite, and our n is tending to infinity. As we introduced here, n is tending to infinity. All right. So here, as we can see, okay, if we tend n to infinity, then automatically these the terms in this series becomes infinite. So if we have to, if we have to, now the converse is also true. Okay. Okay, if someone tells, if someone gives us this thing, then we should understand that it means integration of a to b f of x dx. All right, a to b f of x dx. Okay, so now if we see an infinite series, what do we do is, first of all, if we see an infinite series and we have to find the limit of sum as definite integral, then what do we see, what do we do is, for step one, we express the given series in the form of this. Okay, we express. So I want you all to write this point. Okay, these points are important, this will help us in solving problems. So this is the first point. Okay, whenever we see an infinite series, we'll try to express it in this form: 1 by n f of r by n. Okay, so this is important. Now then the limit is its sum when n is tending to infinity. Now we have to find the limit, and we have to add limit n tending to infinity for this thing, because already we have seen that we have to take infinite number of rectangles. Okay, and this series can be solved by definite integration. Here the converse is also true. This statement tells us replace r by n by x. Okay, so these are the steps of solving the equation. R by n means x over here. If you go back to the definition that we already did, you will get to understand. Okay, and 1 by n by dx, 1 by n by dx. Okay, and limit summation sign by integral. Okay, so as we already know integration, what is integration? Integration, the basic meaning is summation. Integration is like, we can say in layman terms that it is equivalent to summation. But the only thing that integration does is it sums up very minute quantities as well. Very minute quantities as well. Okay, so integration is useful for that. The error is negligible, and hence integration is a brilliant tool in mathematics. So the lower and upper limit the lower and upper limit the lower and upper limit of the integration are the limiting values of the lower and upper limit are the limiting values of r by n for the first and the last term of r respectively. Okay, so note down this point, and then I'll tell you what does this mean by solving a question. We will get to understand more by solving a question. Okay, so here here this is the question. Okay guys, I want you all to check out this question and try to solve this. Okay, like, you can take a minute. I want you guys to check out this question. Okay, so see, what does this question tells us? First of all, see, this is an example of just what we studied right now: 1 by 1 plus n plus, see, this is written, right? If I want to generalize this series, if I wanted to generalize this series, how will I generalize the series? How will I generalize the series? Okay, huh? what is this summation of 1 by 1 plus summation 1 by r summation 1 by r plus n, right? This is summation 1 r plus n. R goes from how much? 1 to n, right? As we can see, 1 plus n, 2 plus n, 3 plus n, 4 plus n, and so on. This 2n can be written as n plus n. So now I can tell you that this n, r goes from 1 to. So what is this r? R is something that keeps changing, okay? Because we are applying, like for the summation, these are the limits, right? For r over r. So r we have to choose such that it changes, and then we apply these conditions r equals to 1 to n by checking how the series has been given. Okay, so our series is ready. What is our series? Our series is 1 upon r plus n, r equals to 1 to n. All right. Now this was the first step. Okay, now we have, so this is in the first step. What I can do here, see, the first step was summation 1 by n f of r by n. Okay, so I have to convert this thing. I have to convert this thing in the form of r by n. So what I'll do is, so that is pretty easy. What I'll do here is I will take n common. So this will become r by n plus 1. Okay, this will become r by n plus 1, and 1 upon n will come out. I hope you understood this. I just took n out. I took n common from r and n. Okay, so now what I can write, see, this series is changing based on r, so n can be treated as a constant. I'll write n outside. Now this becomes 1 by 1 plus r upon n. Okay, so r equals to 1 to n. Now we'll move on to the process that was given to us. Then the limit is its sum when n is tending to infinity. Limit n tending to infinity 1 by n f of r plus n. This we have already achieved. So what I'll do is, now this can be found out by limit n tending to infinity 1 by n into 1 by 1 plus rn. Okay. So now after this, after getting this, what do we do is we replace r by n by x, 1 by n by dx, and limit summation by the sign of integration. Okay. Limit summation by the sign of integration. Now what we'll do is, see, this can also be written as limit n tending to infinity 1 by n. 1 by n was supposed to be replaced by dx. Summation is replaced by summation is supposed to be replaced by integration. Summation is supposed to be replaced by integration. So what will we do is we'll write this as integration. Summation has been replaced by integration. Limit summation has been replaced by integration. 1 upon 1 plus r by n. Okay. So r by n is supposed to be replaced by x. Keep that in mind. And 1 by n is supposed to be replaced by dx. Okay. Now the lower and the upper limit of the integration are the lower and the upper limit of the integration are the limiting values of r by n for the first and the last term. Okay. So what are the limiting values of r by n for the first term and the last term? See, here, here, what will be the limit on x if r by n has been replaced by x? Can anyone tell me? So we have already achieved here in the integration form. We just have to find the limits here. What will be the limits that we will place here, and we'll get our answer. Okay, so here r is 1, and since n is tending to infinity, r by n, that means 1 by n will be 0. So I'll write here as 0. This will be 0. And here, since r is going till n, and n by n will be 1, so 0 to 1. Okay, so this will become as, what is the integration of this thing? Ln 1 plus x, 0 to 1. This can be written as ln 2. Okay, so this is our answer. So let's check the solution also. So you can see here the same thing has been done. Okay, I hope you guys understood this. Let's move on to the next. Let's move on to the next move on to the next slide. Okay, let's try to solve this question. Okay. Okay, guys, come on, try solving the question. So here, similarly, what we did in the previous question, we'll do exactly the same. Here, limit is n tending to infinity. And what is this series? This series can be, see, 1, this 2n is constant everywhere, and 1, 2, 3, 4, these things have been added till where? Till 6n has been achieved. Okay, so 2n plus 4n is equals to 6n. So 1, 2, 3, 4, 5, 6, 7, 8 up to 4n has been added. So what will we do here is we'll write summation 1 upon 2n plus r, and this r is moving from 1 to 4n, correct? This r is going from 1 to 4n. Now what will we do is, similarly, I'll take n common. So I'll write it as limit n tending to infinity summation r equals to 1 to 4n. I'll take n common. This will become 1 upon 1 by n will go out. This will become 2 plus r upon n. Now we'll follow the third step which was given to us. And that third step is I write limit and sum as integration. I'll put 1 by n as dx. I'll put 1 upon 2 plus r by n as 1 upon 2 plus x. Okay. This r by n is supposed to be replaced by x. All right. So what I'll do here is r equals to 1 to 4n. Okay. Here r equals to 1 to 4n is there. So what will be the limit on x? See, x will go from 0. X will go from 0 because for r equals to 1, 1 by n is 0 because n is tending to infinity. X will go till 0. And for 4n, this will go to 4. Okay. So this becomes exactly like the previous one. So let's see what's the answer. See here. See, till here we did. Now I applied ln mod 2 plus x. All right. So what will we get? What we get is ln 6 minus ln 2, which becomes ln 3. I hope you guys understood this. Let's move on to the next slide. Okay. Area under curve. Okay. So what do we mean by area under the curve? All right. So see, there is a curve which is already given to us, y equals to f of x. This curve is like the first thing to be noted is this curve is continuous from A to B, and we have been asked to find the area bounded by the curve x-axis and the lines x equals to A and x equals to B. Okay. So this area can be written as y dx का integration of y dx from A to B. Okay. So the area under the curve can be found by this. When is this applicable? When the area is supposed to be bounded by x-axis and the ordinates. Okay. And similarly, sometimes to trick the students, they ask you questions wherein you will have to find, there will be a curve given to you and you will have to find this area students. They'll ask you to find the area which is bounded by y-axis and the coordinates on y-axis. See, consider this A to B. Sorry, let's take the lower value as A, let's take the higher value as B. Okay. So they'll ask you to find the area between A to B and bounded by the curve and the y-axis. So this area, they'll ask you to find this area. For this thing, the like the most simplest way to understand this is the y and x variable has been interchanged. So this area can be written as integration x dy from A to B. So it's pretty easy to understand, right? Here, when it was supposed to be found by f of x and x-axis, it was y dx. We can see if it is supposed to be found by x-axis, we write dx. If it is supposed to be found which is bounded by y-axis, it is dy. So this is the trick to remember this. Let's move on to the next slide. Now, Now we already know how to integrate functions. Now we just need to find out the meaning of this question and the area enclosed between the curve y equals to x plus 2, x-axis x equals to 1 and x equals to 2. So to do this, students, what we'll do is we draw a graph. First of all, see, in mathematics, graphical way of understanding things is pretty nice, and it's easier as well. So this graph somewhat looks like this, y 0 comma 2. When x is 0, y is 2, it passes to 0 comma 2. And since there are no roots of this quadratic graph, it will look something like this. All right. Okay. So x equals to 1 is somewhere here. So you have to find x equals to 1 and x equals to 2. We are supposed to find this area, okay, bounded by the curve x equals to 1 and x equals to 2. So to find that area, what I'm going to do right now is simply see, this is supposed to be found by the curve and x-axis, like area between the curve and x-axis. So we write as integration y dx, y dx, x goes from 1 to 2, okay, area is this. All right. So now integration y dx can be written as from 1 to 2. Y is given as, in terms of x, it is given x square plus 2, x square plus 2 dx. Okay. Now it becomes easier for us. We already know the integration of x square plus 2. Okay. So what I'll do here is integration of x square. I'll write integration of x square first. Integration of x square is x cubed by 3, 1 to 2, plus integration of 2 is 2x, 1 to 2. All right. So this becomes 2 cube 8, 8 by 3 minus 1 by 3, which comes out to be 7 by 3. Plus now this will become 2 to the 4, 4 minus 1, 3, 3. So this becomes, it is a 916 upon 3 is our answer. I hope you guys understood this. Okay, this was a very easy question. Huh? We just had to remember, since it asked us to find the area bounded by x-axis and the curve, we use dx. Okay, and if we use dx, we use y. So y dx. Okay, let's move on to the next slide. See, 8 by 3 minus 1 by 3, 7 by 3. Okay, here it will be 2. It will be 2, so it will come out to be 13 by 3. Here 2 2s are 4, minus 2 1s are 2. So 13 by 3. Okay, all right. So 13 by 3 is our answer. Similarly, we'll go on to the next question. Now, find the area bounded by this curve. Y equals to sec square x equals to 6, and x equals to 3, and x-axis. I want you guys to try this for a minute. Come on. You guys can do this for a minute right now. This has become easier. Now, this is similar to the previous question. The area is supposed to be found between the curve and the x-axis. Okay. And the ordinates between which you need to find the area has been given. So how will we find? We'll write area. Area is equals to y dx. And x goes from pi by 6 to pi by 3. Okay. And what is y given as? Sec square x. Okay, this becomes as pi by 6 to pi by 3 dx. Do we know the integration of sec square x? Can anybody tell me? Can anybody tell me the integration of sec square x? Huh? So differentiation of tan x is sec square x. So integration of sec square x will be tan x. So what is tan pi by 3? Tan 60 degrees is root 3, and tan pi by 6, which is 30 degree, is minus 1 by root 3. So this becomes 3 minus 1, 2 upon root 3. All right. See here, we got the same result. The answer has been given to us. See, the process doesn't change, okay? The process doesn't change. If we know the process, we'll get to the answer. Note here. See, the thing that has been shown here. Okay, so first of all, I need you guys to understand here is that see the graph of any function can be like anything, right? Yeah, like this. It can be. It can go like this. Okay. So if you are integrating this function, all right. If you are integrating this function, you get the net area. All right. And now what do I mean by net area? See, this area, see, the if the graph is above x-axis, whenever the graph is above x-axis, you get area as a positive value. Whenever the graph is below x-axis, the integration gives us a negative value. Okay. So but the magnitude is equal to magnitude that the integration gives us is equal to area. Okay. And here also, if the graph is above x-axis, the area will get, after integration, will get positive value. Will get positive value. So whenever you are integrating a function, so for the parts that the function is above x-axis, it returns as positive value, and for the part it is below the x-axis, it gives us negative value. And hence, whenever you are supposed to find the area, okay, whenever you are supposed to find the area is always positive. Okay, area is always positive. What we do is we need to remember that wherever the graph is below the x-axis, in that interval we apply this modulus. Okay, we apply this modulus. I hope I am clear why this minus sign sir suddenly comes up, because for this interval a to b, as we can see, the graph is below the x-axis. That means the functional values that the function is taking is negative, and hence whenever the the input of modulus is negative, it comes out as minus of that input. Okay, so that is why this minus sign is there. Okay, we remember, right? Mod of x is minus x when x is negative and x when x is positive. So this property has been used here. That is why this minus sign is there. I want you guys to remember this and keep this in mind, because this question, like this thing is trickier, and they ask questions based on the functions which go below the x-axis. So you might lose marks if you don't know this. So that is why let's not forget about this fact. Move on and let's move ahead. Now, area included between the curve x equals to gy, y-axis, and the abscissa y equals to c and d. So whatever we did for the area included under the curve and the x-axis has been applied here also. You can see I told you, whenever they ask to find the area with y-axis bounded by the curve with y-axis, we use dy. Okay, we use dy, and x dy has been written here. Okay, so y sir modulus is written here. It is written for whenever the part goes towards the left side. Okay, this area here, the graph has been shown on the right side. Consider gy was negative. It was shown on the left side. So gy would have been negative, right? Sorry, yeah, correct. So that is why when exactly then we'll use this property. Exactly then we will use this property. This is similar to the previous property that we read over here. Okay. So graph is going below x-axis. That means we apply modulus. Here it goes left of the y-axis. We apply modulus. Okay. I hope you guys have understood this point. If you are comfortable with finding the area y dx, okay, then you will be comfortable in finding the area x dy also. Okay. Now find the area bounded by the curve y equals to sine inverse x y axis between 0 comma 2, between 0 and pi by 2. So what will we do here is, what will we do here is, since it is asking us to find the area bounded by y axis, what will we do here? We'll write as integration x dy, and y goes from 0 to pi by 2. Area will be this. Okay, and this can be solved as x can be written as sine y dy. Okay, we know that y is sine inverse x, so x is sine of y. Okay, so similarly we can see here, see x has x equals to sine y has been written. Area is written 0 to pi by 2 sine y dy. We know the integration of sine y is minus cos y. We applied the values. We got area under the curve as 1. Okay. And you can understand this graphically also. You can understand this graphically from 0 to pi by 2. 0 to pi by 2, this curve is towards the right side of the y-axis. That is why we didn't have to use the modulus property. Now, find the area bounded by the parabola x square y and line y equals to 1. Okay, students, I hope you guys are understanding the session, and integration is a lot more fun. So let's continue that fun for like, 4 5 minutes more till we have time. Find the area bounded by the parabola x square equals to y and the line y equals to 1. So we know how does the parabola y equals to x square look like, correct? It looks somewhat like this. Okay, my drawing is not good, but my mathematics is good. So y equals to one line. What is y equals to one line? Y equals to one line is this. Okay, here, here. This is y equals to one line, correct? So we have to find the area, this area. Okay. So the trick behind this is, see, what I'll do now is I'll show you a trick. I'll draw just the right portion and I'll find this area. I'll multiply it by 2. Why, sir? Why did you do this? Because why did I do this? Is because this area, this area is symmetric. Okay, y equals to x square is symmetric about the line y, about y-axis, right? So that is why whatever this area, I'll draw it with some other ink for you guys to understand. So this area and this area, from red area and blue area is equal. That is why we only find this area and multiply it by 2. See here, right? I hope you guys understood this. Okay. So our y was given as x square. So first we wrote it as, how do we write? We write integration x dy. So our x is equals to root y. Okay. Our x is equals to root y. Hence this root y has come. Y equals to x square. So x will be root y. So that is why root y has been written on the right side. Now area bounded between two curves. So how do we find? See this area bounded between two curves. So right, first of all, I'll draw a curve. I'll draw a curve like this from blue pen. I'll draw another curve. I'll draw another curve like this. Okay, with red pen. Okay. So why sir f of x greater than g of x? These kind of things has been written. So see for the part this for the part this red ink is above the blue ink. This means this function is greater. This is greater. Now for the part blue is above the red ink. That means that function is greater, right? So just because of that, these things has been taken into consideration. All right. So we write it as area y1 minus y2 dy x1 minus x2. What is y1? The function, first function, y2 is second function. Okay. So we first find out in which interval which is greater. Okay. In which interval which function is greater, and then we apply the normal integration that we have studied till now. All right. Okay, guys. The let's do. Okay. So I want you guys to note down this question. Note down these two questions. Note down these two questions, and I want you to try it yourself. Okay. Okay. So the hint that I'll give all of you is that always try to draw a graph. Always understand the question by drawing a graph. Okay, whenever you draw graph, you get clarity over where and what to integrate. Okay, and what should be the limits, where to apply modulus and all those things. Okay, so drawing graph is very necessary. Not exactly necessary, but it helps. It helps to understand the question in a better manner. Okay, I hope you guys had fun class today. Thank you so much for your time. So first we'll look. Stop share.